Hello. Let's see. Um, okay, should see the desktop now. Okay. Still a lot of people to come yet. Can you hear me? Can you hear me? Can you see the desktop? Everything seem okay?
Yeah, it's all good.
Okay, great. Thank you. Okay. Okay. Let's see. Okay, remember today there's a take-home test. Okay, the take-home test is today. It'll be you can get it from Brightspace at the end of class. You get it from the same page that you were uploading homework assignments to. So the same page that you use to upload homework assignments is where you'll download the exam from and upload the exam back from to there. Okay, and it's due at midnight tonight. There's well, let me show you what the exam looks like. So when you go to Brightspace, you'll download this document here. This is the exam PDF file. Okay, so the first page are instructions about how to fill out the exam and turn it in, and then the problems are on the following pages. Okay, so like as it points out here, like one thing you could do is you could just print this out and write your answers on this page here. So that's one possibility. If you have a printer, you can go ahead and print this out and write your answers just like it was a regular test. Then use your cell phone to scan it back in as a PDF document and upload it. Okay. Another possibility, if you can't print this, you can just write your answers to each problem on a blank sheet of paper. And if you do it that way, please like put this problem and this problem on the first blank sheet of paper, then put problem 3 on the second page, and put problem 4 on the third page. That makes it a lot easier for me to find things if you organize it the same, everybody's are the same way. So you could just write your answers on blank sheets of paper. That'd be fine, and then use your cell phone. And also, I put a link to a couple um, like here's if you don't have an app on your cell phone that'll let you scan in pages into a PDF document, there's this one from Adobe. You know, there's links to where you can download it from, and there's another one from Microsoft, and there's probably many others. Yeah, if you have one, that's great. If you know of a better one, let people know. Yeah, this is another one that'll let you scan pages using your cell phone into a document, a single PDF document. So use one of these after you either if you print out the exam or if you write your answers on blank sheets of paper. Another possibility is if you're good with Word or Google Docs, you could just you could convert this thing to a Word document, I think, but maybe I don't know if you can do that or not. But you could just write your answers in a Word document. You could copy and paste this text into the Word document and then write your answer on it, for example. You could copy and paste this to a Word document and then write your answer on it. Okay. Um, Let me just show you a little trick. If I highlight this text, right now I'm using Adobe Acrobat. Adobe Acrobat doesn't actually well, sometimes it lets me copy, uh, but Acrobat doesn't always work as that well. Um, Here's something that actually works better. This is Chrome here. If you drag a PDF document to Chrome, Chrome is actually a better PDF reader than Acrobat is. Acrobat is essentially they're the people who created PDF, and a lot of machines are set up to open PDF files in Acrobat. Okay, but turns out Chrome's actually better. If you just drag a PDF document to Chrome, it'll just open it and then it does a real good job of letting you copy and paste. Well, I don't think it'll let you edit the PDF document, let you copy from it. Okay. Yeah. So for example, if I copy this code here, for example, I could paste it into Notepad, for example, or you could paste it into a Word document. It lost the format, notice it lost the indentation when you sometimes these things don't really do such a great job of copy and paste. But uh, if you want to create a test document yourself, you can you can use Word or Google Docs. You can either write your answer in a Word document, or if you want, you could copy the problem itself from the exam to the Word document and then answer it in the Word. That way, from your own point of view, you have a nice document. If you copy and paste these into a Word document and then write your answer, you have something that you can use for studying later on. You have a nice document of what your test is. Similarly, if you write your answer on, if you print this out, write your answer on it, and then scan it back in, you can keep that document, and you have a nice example, like for studying for the final exam later in the semester. We'll have a final exam. You can go back and see how you answered these problems. Okay, so it's good to kind of create your own document. Okay, so for completing this exam, any one of these is okay with me. Print it out and write your answers on the printout, write your answers on blank sheets of paper, and then scan them in, or create your own exam document, using Word or Google Docs. And if you actually can edit PDF documents if you have the right software. I almost never do it myself, but I know that you can actually add stuff to a PDF document and save it. So if you wanted to, you could do your answers directly on this PDF. If you have the software that does that, you can write your answers directly into this. Actually, I think I do have a program that does that. I forgot. Let's see. Let me try.
Can we go over any of the problems from the review?
Oh, sure. Yeah, we'll go. Yeah, that's exactly what we're going to do after I show you the idea of the exam. That's exactly what we're going to do, is go over review problems.
Okay, cool.
Yeah, I can't remember how it works, but there are programs that'll oh, there it is. It just took a long time for it to open. So here's a program that'll let me edit. See, I can write into a PDF document and then save it. Yeah, I mean, this is an old program. I don't use it very often. I don't think very many of you would. It's actually an old Linux program that somebody converted to work on Windows. But it's an example of a program that lets you just edit PDF documents. You could type things in and then save your answers directly in the PDF document. If you have a program that works like this one, you can do it that way also. So anything that works for you. Anything that works for you is okay with me, but I want you to send me one document, a PDF document. Like if you use Word, save your file as a PDF document and upload the PDF document. Okay, so even if you use Word or Google Docs, both of them will let you save as a PDF document. So you should upload to Brightspace a single document that has the pages with your answers in them. How you create that document, whatever works best for you. Writing on a piece of paper and scanning it, printing out this thing, writing on it, scanning it, using something like Word, Google Docs, or some other program that'll let you edit this thing directly. They're all okay with me. As professional people learning to do programming, your goal should be to create something neat. Your goal should be to create a document that you would be proud of. A document that you would find neat and presentable. Okay, so one of your goals is to create something that you would show to people. Okay, because believe me, job interviews for programmers now are doing this. People are taking tests now as part of job interviews. That's not that unheard of anymore. It's getting more and more common. I point out to you things like Coding Bat were being used for interviews. People will watch you, solve problems. They'll see how you write, how you present, how well, how quick, everything you do, they watch. Practicing to do things neatly, trying to get used to these tools, be good at using these tools, be good at scanning, be good at uploading. They're all valuable skills, and I mean, I really mean it. They really are valuable skills, and they're getting more valuable. Companies judge people on some of this stuff. Actually, many companies judge people on much of this stuff. Okay, so all right, now after you've made your document, you'll upload it at Brightspace, just like you do the homework assignments. When you're done, you'll upload it to Brightspace just exactly the same way you upload your homework assignments. Here's what I want you to name your final file. This file is called CS123 Section 2 Exam 1, and then just add your last name to the end of the, add your last name. That makes it much easier for me to organize it. So just add your last name to the name of the file and upload it. Okay. Any questions about completing or turning in the exam?
It can be left as a PDF. It doesn't have to be converted to a zip for this one.
No, actually, you're better off just uploading the PDF directly. There's only one document. So the zip file is really because you would have multiple documents. And so, one document, upload your PDF directly to Brightspace. So that's simple. You don't need to create a zip file. Okay. Other questions about completing or turning in the test?
So just a PDF file with our answers. Do we have to include the questions on the file that we turn in?
No, it'd be nice if you could. I mean, it'd be good for your point of view, and it helps me. You can copy and paste. It's not hard to go copy. But if you're writing the answers on a blank sheet of paper, no, I don't expect you to write out the problem. Okay. So if you're doing the strategy of just writing your answers on blank sheets of paper, no, I don't expect you to write the problems out. That would be too much of a nuisance. If you're like creating a Word document, it's real easy to copy and paste these problems into the Word document, and that just makes it more readable even from your point of view. But if you're writing the problems out on pieces of paper, no, you don't have to. You don't need to write these problems out. But do put the problems, like put problem 1 and 2 on the first page, put problem 3 on the second page, put problem 4 on the third page. But you don't. If you're writing them out by hand on blank sheets, you don't have to write all that. Okay. Okay, other questions? Yeah.
Yeah. Was the length of the test going to be around the same length as the review?
The length of the test is 9 problems. Okay.
All right. Yep.
Yeah. So that's half the review. It's a little less than half the review. It's 9 problems. Okay. Other questions about turning in or completing the exam? Oh, and one comment. While you're taking the exam, if you have questions, send me an email. Okay. So if you're a little bit worried about what a problem's asking for, if you think you might be misunderstanding it, if you want a clarification, send me an email. Yeah. So you have every right to send me an email while you're taking the exam and ask a question. Okay. And I'll be watching my email during the evening, and I'll try to answer them pretty quickly. So if you are unsure what something's asking, if you want a little bit of clarification, send an email. If you're really desperate, you can maybe ask even for a Zoom meeting. But usually, I think usually people have simple questions. They just want a little clarification. So an email, a quick email will usually solve that. So you have the right to ask questions about email. Everybody's supposed to do the exam themselves. This is essentially, it's like a take-home homework assignment, but you're supposed to do it yourself. Okay. So everybody's supposed to write their own answers. You shouldn't be communicating with anybody in the class, but you can ask me questions. I won't tell you what the answer is. So don't say, how do I do problem 3? But if you're unsure about, you might be misunderstanding, you can send me an answer and say, is this what you meant? And I can tell you whether it's right or wrong. Yeah. Okay. So if you want a clarification, if you're unsure of something, send an email. Okay. Let's see. Well, anything else?
We have until midnight, right?
Yes. Mm-hmm. Okay. Okay. So let's see. Okay. Any more questions? Well, if you have questions, if you think of something during class, just unmute and shout out the question. So if you have a question, just bring it up. Okay. So next, let's. Okay. Question about the review problems. So now's a good time to really look at.
I have a couple questions about the questions towards the end. The starting problems were mostly pretty easy.
Mhm.
But one of the questions, let's see if I can find it. It was about the turtle. I think it's number 15.
Yeah.
So it creates, or you could say, I think the terminology is invokes a turtle object,
No,
right?
create. Actually, the right word is no, not invoke. The word is
Okay.
create. Yeah.
Okay.
That
Okay.
well, new creates a turtle.
Okay.
The word
Okay.
invoke, when it's used, is here. You
Is
invoke
where?
here. Can you see that? Does it show up? Can you see that what I'm
Okay,
highlighting?
so I invoke the turn right method, you could
Yes.
say.
Yeah. The word you invoke a method, you create a turtle. The word invoke, some people like to use it. I usually just say you call the method. And the textbooks we're using refer
Okay.
to it as calling the method. But you invoke a method, you create an object. Okay.
Okay. Okay, so it asks for what, the final direction on
Yes.
number 15 or 14? Let me see.
It was 15. 15 asks for the direction. 15.
Okay, so it creates the Alice object, and then Alice turns right. And then when it says turtle Jane equals Alice, it's essentially assigning a new name corresponding with the Alice object.
Yes. Yes. Mm-hmm. So
Okay.
now turn.
So when I invoke turn right on Jane, I'm essentially changing the direction that Alice is going.
Exactly. Mm-hmm.
Okay, so okay. And
And
then I
then that
just keep
happens.
track.
That happens again here, right?
Yeah.
Mm-hmm.
Okay.
Yeah. So here, I think I can show you. Like, what would the answer look like?
Hmm.
Okay, you're asked to draw a picture. So let me draw the picture using this tool. I mean, you can draw this if you're doing this on the exam, you can just use your paper and pencil. But here's the idea. First line, I create a variable called
W.
W, and I create a. I wish I can do this faster. I create an object. Okay. And right now, see, this line here creates the variable and the object, and the variable points at the object. Okay. And this
Okay.
guy is a world object. And this is a world variable. Okay. Now, next line, same thing. Now it builds a Alice turtle variable pointing at a turtle object. So you'd have
I don't know if I understand the way you set up the world W with the variable and the object. Wouldn't it just be the W?
no. That go back to the course website. Look at when we first introduced turtle objects. So
Okay.
here was okay. Now look at this picture here. See?
Okay.
Remember? See, I mean, this is essentially that homework assignment is just this problem here. World variable pointing at world object.
Okay.
Turtle variable pointing at turtle object.
Okay.
And another turtle variable pointing at the same turtle object. And then this turtle variable
Okay.
pointing at a different turtle object. But the
Okay.
variables,
So the variable points at the
object.
object.
Yeah.
It corresponds
This
with.
guy is not this guy here is not the turtle. This guy is a turtle name. And this is a turtle name. These are turtles over here. We separate the turtle name from the turtle object. And that's what the code does. Okay. And that's why these memory diagrams are important, because that's why that and that make the same turtle turn. When you say y3.turn or you say uRTL.turn, you're turning the same turtle. It's not that this is one turtle and this is another turtle. Okay, they're the same turtle. Okay.
Okay.
So over here, so over here, I'm going to have there's a turtle object called Alice, You know, so if I, I would fill in this picture. This is Alice. Okay. I'm going to end up with, and then Alice is going to, Alice points at this turtle. Okay. Then that turtle's got a heading of 90 degrees. When you tell him to turn, his heading changes. Okay. Now the key is what happens here. Yeah. That creates, on the left, it creates a turtle variable. Okay. On the left of the equal sign, it's a turtle variable. So that's just a box over here, a box on the left. Okay. It's a turtle variable, and it's given the name Jane. Okay. What about the right side? It doesn't create another turtle object.
Is it just pointing to Alice?
Right. Well, it points at the same object that Alice is pointing at. It points at the same object that Alice is pointing at, because what you're doing is you're going to copy Alice's arrow into Jane. So you copy that arrow into Jane, and now points at the same turtle. This is, yeah, it's really kind of tricky. This is not Alice. Alice is a variable that happens to refer to that turtle. But that turtle is also referred to by Jane. So you could say that this turtle is both Alice and Jane if you want. It's got two names. The turtle has two names. But like I mentioned, you're not your name. You know, you and your name are different. You know, it's like a philosophy question. But the truth is, you are not a name. You are a person. Okay. Alice is not a turtle. Alice is a name. It's a name for a turtle. And it's very distinct. You know, in Java, these are very distinct ideas. The variable Alice sits over here in memory. And in a real computer, it's really a different memory location. This is one memory location. This is a different memory location. These are different things in Java. This is the variable that refers to a turtle. And these two variables here refer to the same turtle object. If you say Alice.turn or Jane.turn, you're turning that turtle there. Okay. And then this line creates another turtle variable. See, that's on the left-hand side. That's a turtle variable. So that's still another. That's a third turtle variable over here. Okay. This turtle variable is called Joe. Now, what goes into this variable? Whatever's in Jane gets copied into Joe. Well, so this arrow gets copied to here, and that gives us a third name for what was originally just called Alice. Okay, so there's the memory diagram.
So if it was making a whole new turtle, then on the right side would be another turtle object?
Yeah, see, I only made one turtle in this example. See? Creating a turtle always means you use the word new. Okay, and
So
I
like
actually only created one turtle in this chunk of code. So there's only one turtle box over here. And yeah, it's real important. Turtle objects are only created by new. Turtle variables always are created on the left side of an equal sign using a declaration. So the equal sign, and the equal sign we think of as the arrow. Create the variable, create the object, make the variable point at the object. Create.
So when we say, oh, sorry, I didn't mean to interrupt.
Oh, go ahead.
Okay. So when we say we're creating a new turtle, when we in the statement turtle Alice equals new turtle, parentheses W. So are we saying we're creating a new object within the world object?
Well, when it's drawn, he's not it. No, this object is not inside that object. When he's drawn, this turtle is drawn on the coordinate system that this world represents, and that's kept track of by Java.
Okay.
What actually happens is that this turtle keeps a little arrow inside this turtle somewhere. There's going to be an arrow pointing up to this world where he actually lives in. So this turtle needs to know what world he's going to be drawn in. Okay, so that ties them together. I could have multiple worlds and multiple turtles and have some turtles on one world and some turtles on a different world. We actually did an example like that in class. I think we. Yeah, see, this one had two worlds. There was a world, a first world, and a second world. And some of the turtles were on the first world, and one of the turtles was on the second world. Yeah, this turtle was on world 2, whereas this turtle was on world 1. And when you ran this program, you would see two windows, and one turtle would be in one window, and the other turtle would be in a different window. Okay, so you could have multiple worlds and put turtles on different worlds if you want. Okay, so when you create the turtle, you need to say which world the turtle's on. So you say new turtle, and you say which world that turtle's on. Okay, all right. That's the only thing you need to tell the turtle. You need to tell the turtle when you. Now notice, what do you tell the world? What are those telling?
Create a 400 by 400 pixel.
Yeah, how many pixels wide and tall the world is. That tells you how big the world is. You know, if you create a world of 10,000 by 10,000, it'll cover your whole desktop. You know, so 400 by 400 is it's like the size of 400 by 400 would be a window about that big. That's about 400 by 400. Okay, that's about that size window there. Okay, so you tell the world how big to be. You tell the turtle what world he should live in. Okay. Then when you tell the turtle to turn right, you don't say anything here because turn right means 90 degrees. So you don't say in here about how much to turn. Turn right means 90 degrees. And it's Alice that's turning right. It's Jane that's turning right, but Jane is?
Alice.
Alice. Yeah, Jane and Alice are really the same turtle. So that turtle, in this problem, the turtle is turned 1, 2, 3 times. So he's going to end up facing west. Yeah, he was facing north, then he turns once and faces east, turns once more, faces south, turns once more clockwise, and ends up facing west. So this turtle will end up facing west because he's turning it's one turtle and he's turning 3 times. Okay, and here's the homework. This is the picture the homework is asking for. The picture is 4 variables and 2 objects. A world variable and a world object, 3 turtle variables, and 1 turtle object. And if I wanted to be real careful in this picture, I might point out that this is a turtle. That's a turtle variable. Okay, it's a turtle variable named Alice, pointing at that turtle object. This is another turtle variable named Jane, pointing at that turtle object, same one the other one does. And this is a turtle variable. Okay. What kind of variable it is, what I called it, and what's in it. Yeah, that's what your memory diagram should show.
When we make our memory diagrams, are you gonna want us to include the characteristics within the object? For
No.
example, the world has 400 by 400.
No, you can leave these boxes empty.
Okay.
We mentioned like if you go back to that in class, I drew them a little bit more detailed. I showed the data that was in there. This was a 500 by 500 world, and it was got 1 turtle on it. And this was, well, I didn't write the numbers, but this turtle's got some location, some pen color. You do not need to, you can draw your memory diagrams with just a box here. You don't have to put anything in it, okay? You do need to show the variables on one side and the objects on the other side. And yeah, I don't care if you bother to fill in what's inside the object, right? For now, it doesn't really matter, okay? It's important as we go on to think that there is data in it. You know, this turtle is in a different place than that turtle is in the world. So there could be different numbers here for the location of that turtle than there would be numbers here for the location of that turtle. Okay.
Professor.
Mm-hmm.
How would you show that the specific turtle's made on a specific world?
You,
Like,
you,
assuming there's more than one.
yeah, you don't need to in your picture. Yeah,
Oh, okay.
yeah. Here, there would be each of these turtles has got an arrow pointing to the world that he's on. And like I say, for the homework, for the problem like here, the picture should be the variables and the objects. And yeah, you don't need to show that this is a 400 by 400 world, and you don't need to show that this turtle's on that world. So your picture, this is good enough. See, that would be, I think, the right answer for this problem. The turtle variables, the turtle objects, and the world object, just leave them blank. You know, it's a world object, you know, it's holding data, but you don't have to, you know, you don't have to say what's in it. The key
Okay.
is that, see, this picture helps you understand. See, this picture solves the problem of why the turtle's facing west. Because you called turn right on that name, you called turn right on that name, and you called turn right on that name. If you weren't very careful, you'd think that there were 3 turtles, and every turtle's facing east. Okay? But, yeah, because you have this turtle turned right, this turtle turned right, and this turtle turned right. But this picture says, no, that's not the case. Those names are all synonyms for the same turtle. So this turtle is facing west because he's been turned 3 times. So see how the picture, the picture is helping you to solve the problem of what does that code really do? Okay, so the picture helps you realize that all these turn rights are turning the same turtle. So the turtle's turned 270 degrees. Turned 90 degrees 3 times, that turtle's turns 270 degrees. If there were some other turtles involved, this picture would help me realize that maybe this is turning one turtle and this is turning a different turtle. See, the picture would help me realize what's going on. Okay, I can even do weird things. Like let me modify this a little bit. What did I just do? I added 2 more lines.
You made Jane a new turtle and
Yeah.
then had it turn right.
Yeah. Now notice how this line of code is not doing the same thing. This, you know, see, what's the key here is compare this one with that one. You would think that if you see the same line of code in 2 places, they're doing essentially the same thing, but they're not. This turn right does what?
Turns Alice.
The one that was called Alice, and this turn right does what?
Turning a new turtle.
Turning a new turtle. And see, you notice you can't say it's turning Jane, because this one turned Jane. See how carefully you have to read it. Don't say, oh, that turned Jane. Then why is that one different than this? Because that one turned Jane too. This one turned the first turtle we created.
Could you,
This one turned the second turtle we created. So they're turning 2 different turtles.
could
The
you
picture would
draw
help you
that?
see that.
Yeah. Can you
Okay.
show us how it would look in a memory diagram? Does Jane, the new turtle, replace the
Yes.
object the
Yeah.
old Jane was
Okay.
pointing
So
to?
so when we get to this, now we get to this line here. The picture is going to change. I'm going to create now I don't create a new turtle. No, notice I'm not creating a new variable. How do I know I'm not creating a new variable?
The variable already exists. You're just reassigning the variable
because-
to a new turtle.
Yeah, what creates a variable is when you use a declaration. See, that creates a variable. Here, I'm not creating a variable, I'm reusing one. I didn't put the word turtle in front of there, okay? So I'm working with that Jane, that variable there. But I am creating a new turtle. So I go over to my picture and I've got a new turtle. Here's my new turtle. It's a turtle object. Okay, now what I'll do is I'll erase that arrow because it's not going to be relevant anymore. Erase that arrow and replace it with a new arrow. Now Jane points to that one. See? So the Jane variable is updated. It's like saying x equals 5 and then later on saying x equals 7. The variable x gets replaced with something. It gets updated. So the Jane variable, so on this line, Jane was pointing to this turtle and it made this turtle turn right. This line made Jane point to a new turtle, and then this line made the new turtle turn right. Okay, so now this is the memory diagram when this code is done. Okay, now notice in this picture, it doesn't show the fact that Jane moved because the picture is a snapshot in time. Every picture is a snapshot in time. This is what the picture looks like at essentially at this line of code here, actually at the end of it. Okay, so it doesn't show me what the memory looked like at this point in time. At that point in time, there was a different memory diagram over here. Right now, this picture as it's drawn is the memory diagram at the end of the program. Usually on the homework and in the exam, I ask for the memory diagram at the end of the program, which means you might have to update your program. Now, the way you do it is you draw your memory diagram line by line by line, but at some point you may need to erase something and update it. See, when I got to this line here, it made me erase an old arrow. It made me erase an old arrow and replace it with a new arrow. So the problems are usually asking for the memory diagram when you get to the end of the code. So not on this exam, later on, I'll put line numbers on these. And I might say, what's the memory diagram at line 7? Okay, like I could say, draw me the memory diagram at line 6. It's a snapshot in time. So you would just follow your nose from 1 to 6 and stop at 6. That would be the memory diagram at 6. That's what the Java Visualizer does. When we step through programs, the Java Visualizer steps through the program and draws the memory diagram. If I don't say otherwise, I usually mean the memory diagram when you're done, at the end, like this one is. Okay? So your memory diagram should be variables on the left, objects on the right, arrows connecting them. Don't worry about what goes in the object. Just leave the objects empty. Okay? Put a name on them though. It's a world object and a turtle object. Don't just draw boxes. Say that that's a world and that's a turtle and that's a turtle. And it's even good to put names on the variable. The variables have a type and a name. So that's a world variable called W. That's a turtle variable called Alice, turtle variable called Jane, turtle variable called Joe. Okay.
So
Mhm.
another problem we had to do, it was the same memory diagram idea, but with strings. And so in that case, we would just switch it to different string boxes and string variables, etc.
Yeah, you would just put the word string up here. That'd be good enough. And string variables. Okay. Now let's look at the example. This one. Now this one, since it's using strings, I can take this one and put it into the Java Visualizer. The Java Visualizer will not work with turtles. I wish they had turtles built into the Java Visualizer, but they don't. So you can't take your turtle code and put it up on the Java Visualizer. But this one I can. So I'm going to go over here and let's see how the Java Visualizer does it. Okay, so here's the code from that problem. Just paste it into the Java Visualizer. Okay. Now, just jump up to, let's see. Oh, there's a misprint in here. I forgot. That C was supposed to be uppercase. That's supposed to be an uppercase. There was a little misprint in the exam. That C right there was supposed to be uppercase. Okay. Oh, and to get Java, the visualizer, to draw nice pictures of strings, you have to check this box here. You have to remember that. The Java visualizer otherwise doesn't draw the right picture for strings. I have no idea why in the world they chose to do that. But the default pictures are not the ones we want. They're not the true ones. They're like abbreviated, simplified pictures that don't help actually at all. Okay, so click that box and click that checkbox there. Okay, now, okay. Notice that box there is our equivalent of, that's the variable. See, that's the variable box. You can faintly see that there's a box there. Okay, and it's called salutation. Now they don't write the word string here, so they don't label, but they do label the object. See the objects up now, they didn't even put a box around it, but the object's over here, and it's a string object, and it's holding greetings. Okay, so and there's the arrow. Okay, so that line of code created a string variable, a string object, and made the variable point at the object. 1, 2, 3 pieces. You know, string variable piece 1, string object piece 2, and make the variable point at the object. For strings, Java doesn't make you write the word new. If you wanted to, you could write this in a verbose way, new string. Java doesn't make you do that because strings are so ubiquitous. They let you do this in a shorthand way. So you don't have to say new string holding greeting. You can just say greeting, okay? So that's kind of a shortcut that Java gives you, okay? All right, so first line, one piece of the memory diagram, okay? Does anybody remember? This is a tricky little part of the problem. What does line 5 do? Let's just, what does line 5 do? What do I see over here?
You'll see greetings in all caps.
No, you'll see nothing.
You'll see nothing.
Oh,
Why?
darn.
What was the rule about strings? When you call,
It's not going to save it to anything. It will just disappear. It needs a variable.
okay, back up a little bit. What does it do though? You said it doesn't save anything. What's there to save?
Makes a copy.
Makes a copy. Yeah. Strings make copies of themselves and make the changes in the copy. Unlike, when you tell a turtle to turn, the turtle turns. When you tell a string to uppercase, the string makes a copy of itself and makes the copy uppercase. So this creates a second string, but we didn't print it or save it in a variable, so it disappears on us. So let me show you. Well, okay.
Really quick, is that garbage collection in Java?
Yes, it's called garbage collection. Yeah, the object's created and it's garbage collected because you didn't save it in anything, so it becomes garbage. See, nothing happened. I just finished 5. I'm on to 6. 5 is done. Nothing happened over here. The to uppercase method did not change this object. It created a copy, but we didn't save the copy. If I want to see that there was a copy, I can create another string variable, I'll call it S5, and save the result in that variable. There's that. See, that was the object that was created, but then garbage collected. Now I said, no, I want to give a name to it. So I give a name to it, so that keeps it around. Notice that this guy is unchanged. Okay, right? But if the way the problem was, that line doesn't affect the memory diagram. So it's kind of a red herring. It was put in there on purpose that line does not have any effect on the memory diagram because there's no, that result's not saved in any way. Okay, now what does this do? What's that going to do to the memory diagram?
It's going to make a new string variable called S2, and then it's going to connect it to an object that is 0 through 5, which would be greet from salutation.
Right. So there's a since I'm calling a method on a string, I'm actually building a new string object. So this is not going to abbreviate this guy, just like this one just like this one did not uppercase this one's not going to truncate this one. It's going to create a copy. And then this variable will be a name for that copy that's the truncated version of this. There it is. Okay? So S2 is a name for a new string that's this guy truncated from 0 to 5. Okay? So there's the memory diagram so far. Okay? Now line 7, what does it do?
It's going to make another new string variable called S3 on the left-hand side, and then a new object that has greet, but with a lowercase g.
Yeah, because this does not change what's in this guy. It keeps creating new strings. So now I go back to, well, actually, it's going back to this string. See, it's S2. So I'm going to S2. I'm lowercasing S2, but that's creating a copy of S2 with the lowercase in it. So it creates a string called S3 with GREET in it. Okay. If I'd have put an S1 here, it would be lowercasing this one, but I put S2 there, so it's lowercasing greet. So forward. Okay, there it is. Greet. It lowercase this one to create a new name. Okay. Now this one's a little bit trickier. What does this do?
It's going to make another new string variable S4, and then it's going to have the object from S2, which is greet, and the object from S3, which is greet with a lowercase, and then there's no space there, so they're just going to be smashed together.
But careful, you said it's going to take this object, which is this string, and it's going to take this object, which is this string. Okay, but then what does it do with them?
It stores them into S4 as a new object.
As a new object, right? See, that's the key thing. The plus actually has to build another string object. It does not take this thing and put it on the end of that thing in there. Because it's not going to change S2. It's not going to change S3. It's going to use them to build another object. So it's actually going to create a new object, even though the word new is not in there. Just like the word new is, notice that strings are weird. They create new objects without you having to say new. So this takes what's in that string, and concatenates them together in a new object. See, there's the new object, and makes S4 a name for it. So I end up with 1, 2, 3, 4 string objects. I only created one string object. Actually, a fifth one was created in Lost. This created a new string object, this created a new string object, and this created a new string object. And there's actually a fifth one, but it got lost. It got garbage collected. Okay, so there's the memory diagram at the end of this. 4 string variables and 4 string objects in this case. There's no aliases here. I can create one. String S5 equals S4. Okay. Now, new string variable. Notice I'm not doing anything to S4. I'm not tacking on anything in the end. I'm not calling any methods. So this does not create a new string object. Notice the rules are kind of funny. See, no new string object. Since I didn't do anything here, it just says, oh, I'll just make S5 another name for this one. This built a new string. This built a new string. This built a new string. Here, there's nothing to build a new string, so just let S5 be an alias for S4. 2 names for the same string. Okay, so there's the same kind of, that's the kind of picture we had over here. When we had 2 arrows pointing to the same turtle. Alice and Joe point to the same turtle in this picture. Now S4 and S5 point to the same string here. Notice memory diagrams over here are just like the memory diagram I drew in longhand here. Unfortunately, the Java Visualizer won't draw a turtle memory diagram, but see the idea. Variables on the left, a variable is a little box. The variable holds something, it's got a name. If it's a reference variable, it points to an object. Let me tack on a few more things here just to show you. Like what if I do int n equals length S4 dot length? What's the memory diagram going to look like now? What's that going to do?
It'll add another variable, but it's going to be an integer variable, n, and then it's going to assign an object equal to the length of S4.
No, integers aren't objects. So,
Oh.
so it's going to create an integer variable over here. And it's going to compute the length of S4. But what does it do with the answer?
That in the box.
Puts it in the box. See, that's what we call a primitive variable. If this was the Python language, the 10 would be an object over here. If this was Python or JavaScript, the 10 would be an object over here. There'd be an integer object over here with a 10 in it, but not in Java. In Java, the integers are primitive data types. So they actually get stored right in their variable. See, the 10 is in the variable. There's no arrow. What other primitive data types do we have? There's several of them. For example,
Character or char?
yeah, char. Yeah, so let's do that one. Char C equals S4 dot char at. What's the seventh character in S4? S4, the char at location 7. Now that's a single character. Okay, you can count through here. S4 was that string. You count starting at 0, 0, 1, 2, 3, 4, 5, 6, 7. Over it's that E there, I think. Okay, notice it's a primitive data type. There's no character object. There's string objects, but no character object. This was Python or JavaScript. C would point at a character object out here, and N would point at an integer object out here. But that's not the way Java works. Java made the integers and the characters primitives. So they get stored right in their variable. And another one is I want to ask, does S4 start with hello? That's asking a question. Does S4 starts with that string of letters? And the answer is either yes or no, but we don't write, the answer is either true or false. It's true that it starts with that or false. And that's another example of a primitive variable. See, there isn't a Boolean object over here. There's a Boolean variable, and the answer goes right in the Boolean variable. Tricky, tricky. Yeah, Java made an arbitrary decision that some things are objects and some things are primitives. So some variables hold arrows to the objects which are over here, and some variables actually hold their value right in the variable. Okay. Now, if you go back here and uncheck that box, now watch what Java Visualizer does. What did it do? You can give me you can kind of use words now. What did the Java Visualizer do? What did it pretend?
It pretended they were all primitive.
Yes, it pretended its strings were primitives. For some bizarre reason, they think that makes it easier for students to pretend. That's exactly what they're doing. They're pretending that strings are primitives. I think that's a bad idea. But you can, different people have different ways what they think are ways to teach. There are some people who in an introductory course kind of sort of tell the students that strings are kind of like primitives. But then they wave their hands and say, well, they're not really primitives, but and then it's a mess. What they are is they're objects. They shouldn't be doing this, in my opinion. But that's what they do. By default, they pretend that strings are primitives and that they're stored right in their variable, like integers, characters, and booleans. Personally, I think that's a big mistake. So, but they at least give you a box to change that. Now, this picture is what Java really is doing. This is what Java does. Strings are objects. So the string variables hold arrows, pointers to the object. Okay, so this is what Java does. The other one is not what Java does. But now you can see what they chose to do. By default, they were choosing this funny thing of, let's pretend strings are primitives. I mean, I don't know why. Okay, other questions? What about back to here? We've only done a couple problems. What about back to here? Other problems?
Can you talk about number 20?
Okay.
Thank you.
Let's put it. Almost every one of these problems, you should put them in the Java visualizer to get a sense of what's going on. Solve the problems using the Java visualizer. So I'm going to go here. I'm going to open another Java visualizer. You can open as many of these as you want. One problem in one window, another problem in another window. Okay. That example is a method, so I need to put it outside of the main method. Okay. This method is supposed to find the last digit in a number. So like the number 124, the last digit's 4. The number 27, the last digit's 7. Okay. Now, you don't really need to understand what this is doing, but you can kind of go, here's what's wrong. If n is a strictly positive number, here's what you give back as an answer. You return that answer. If otherwise, see now, if n is strictly positive, answer this way. Otherwise, if n is strictly negative, answer this way. What's the problem?
What if it were 0?
What about 0? Yeah, see, they didn't, the mistake they made, and if you ask Java Visualizer, it tells you there's a missing return statement. You didn't say what to do when n is 0. So what you can do here is you can say, well, there's still another else. This is the case when n is 0, and I'll just return 0. Okay, and now, see, that fixed the problem.
Isn't that final else redundant?
Yes, good. Yeah, the final else is actually a little bit redundant. I put it there because that's kind of considered good style, but if I did like this, it's still okay. See, it actually, it's redundant, but it's kind of good style to put it in there, okay? But it is redundant, okay? And then you could, if you want, you can say, find last digit of 124. Okay. See, now, if I visualize this, it goes in here and works, but where's the answer? The final digit of 124 is 4. What happened to the answer? See, if I go here to the end, what happened to the answer? Hint, what happened to the salutation?
Collection.
Pardon me?
Oh, like the other student was talking about before with garbage collection.
Okay, here it was, now, over here it's not garbage collection, but it's close to it. What was the problem here? Why didn't we see the result?
Because it was never assigned to a string.
A variable. It
or
wasn't
a variable.
assigned to a variable. We didn't store it anywhere. What's true about the answer from him?
It wasn't stored or
It wasn't stored anywhere or printed. I could print it down here using system.print, or I could store it. I'll store, let's see, I have to go back to edit. Okay, I can store it int x equal, okay. There, see, the last digit was 4. See, now I went to the end of the program, but see, now I know what the answer is. The last digit, 124, was 4, but I stored it, okay. If I didn't want to store it, I actually could have also done the following. Now, run it now. Go to the end. Now, notice that I didn't store it. See, the answer 4 is not up here. Where's the answer 4 now?
In the output.
In the output. Now, which is better, storing in a variable or putting it in the output? And the answer is they're both real important. Sometimes you need the answer in your output. Sometimes you need the answer stored in a variable. It's one of the things we have to learn is how important these two things are. When should you send an answer to the output? When should you store the answer in a variable? The bottom line is the following. If you need the answer later in your program, it has to be stored in a variable. If the answer needs to be saved somewhere, like in a document or in a file, then it should be sent to the output. Okay, you send things to output when they need to be stored forever, essentially like in a file, or they needed to be displayed in a GUI. But if you need this result in your program, you can't send it to output. You need to store it in a variable. Okay, so you store things in a variable. You store things in a variable for later reference, but you print things out if that's appropriate, if you need to send the answer to somewhere. But those are really different ideas. Like, so now I do both. I've got the variable holding the answer, so it could be used somewhere else in the program, but I also have reported it to the output in case there's somebody who's looking for it. Okay, so those are different ideas. But I have to do something with that. See, if I don't do anything with it, like that. See, if I don't do anything with it, that's bad because the number, it's just like over here, garbage collected object. Here, it's just a thrown away answer. The answer is an integer and it's just thrown away. Here, the object gets garbage collected. Here, the integer, it doesn't get garbage collected. It's technically a different thing here, but the integer does get thrown away. Okay, but on your hand, if I do that, then, then I store the answer or print the answer. Okay, so that's what this problem was. It was really just, can you, check, there was a hole there. That and that weren't enough. Strictly greater than 0, strictly less than 0 left you with needing a third case. Okay, what about another problem?
So in regards to any problems asking us to describe errors, will it ask us ever to describe like the exact kind of error that's occurring?
No, they're so obscure. Yeah, that's a good question. The errors are so obscure that I would never say what is the exact error that Java did. Oh, now, but see here, this is, I would expect you to answer the logical error, not the error message that Java gives. But yeah, you should be able to say that there's a hole in that logic. It said what to do for positive numbers. It said what to do for negative numbers. It didn't say what to do for 0. So you should be able to describe in words the error in logic, but not give me what the error message from Java is going to be. I would never ask you what the error message from Java is going to be. So you see the difference? Yeah. You should be able to describe in words what's wrong with some logic. What's the mistake the student made? What's the mistake the programmer made? But I'll never ask you what error message is Java going to give. Like up here, find syntax errors. I'm not going to ask you what the syntax error messages are, but where are there syntax errors in this? So you can find the errors and just circle them and correct them. Like, so, find the little errors. Okay. Missing semicolon right there. For example, there's missing semicolon there. So you can, like, on the exam, if you have a problem like that, if you're working on this copy, just fix the problems and circle where you fix them. If you're writing your answers out longhand, you could write out what that answer looks like corrected. You could also just say things like, there's a missing semicolon at the end of line 5. Yeah. So you could also describe, it says find 3 syntax errors. So you could say, like, missing semicolon at the end of a line. Which line? There's a plus missing here. So you could say in words, there's a plus missing. Yeah. But probably the easiest thing to do would be just write out that code with the correct. If you're writing your answer on the document itself, you can just make the corrections right there. You could put a semicolon there. If you're doing your problem on a blank sheet of paper, probably just want to write that out with the corrections made. Or if you want, you could describe in words what they are. You don't have to give me the compiler error messages, but you could say there's a semicolon missing from the end of such and such line. There's a plus missing before the X on that line. And the other one here is there's a brace missing after incorrect. See, there should be this brace here doesn't have his companion brace up here. So there's a brace missing after. So you could answer it in words. Okay. So it depends on how you're doing the exam, how you would describe these errors. Okay. Other questions, other problems? I'm looking at the chat to see if I missed any question. Was there any question asked in the chat that I didn't answer? So number is 16 different? Let me see. Did we do 16 already?
We went over it. I think that was the string one.
Yeah, that's the string one. Okay, yeah, that's the string one. Mm-hmm. Anybody got one that they, any one of these problems anybody could think of they want see how talk about it? Still got a few more minutes of class.
I guess for 21.
Mm-hmm.
Just the ending where after it says if B is greater than A, result equals. I'm assuming that you'd want to have it be B.
Yeah. Now, why? What? This is kind of. What's your reasoning there? Why would you put a B there?
Because it's greater than A.
Yeah, but why B? What's what is the goal of this?
You want to find the max?
Yeah, see, the name of the function was max. You're trying to find the max of, well, there's 2 numbers here. See, that's an int, and well, probably that's an int also. So this should be int A and int. Well, you could put Bob here if you wanted, but then you see that there's a B here. Where did that B come from? The only place where it could come from would be over here. So there wasn't Bob or Alice written here. It probably was B, because that A is this A, so this B should be this one. Now, it wants the max of 2 things. Well, if B is larger than A, what does that tell you?
That's the max.
That's the max. So the result should be B. Well, then why was this line here?
To trick you?
No, actually, no, not to trick you. It needs to be there.
Actually create the variable?
Create the variable, but what if I just dropped the equals A? What if I just created int result? I need to create the variable to hold the answer. So I'm going to return an answer. But why did I set it equal to A? What's the reasoning here?
Was it to show that after max 2 that the a is an integer?
No, that's up here. This will be an int. A is an int. No, so A has to be said. This needs to be int up here. Okay, so you have to put the word int here. And then the result is also another int. So that's not saying that A is an int. That's said up here. This is saying that result is an int. Why do I put A into result?
Would it be a default decision?
Yes, it's the default answer. One of these is the max, right? If you give me two numbers, one of them is the max. So I say, well, let's guess that A is the max. What if this is false?
It'll
You-
just return a.
Then it'll return A. See, I needed to make sure, I need to put an initial guess in here. So if this is false, then I'm returning A. But if it's true that B is larger than A, then what am I doing here?
Changing the variable to b max.
Yeah, I'm updating my guess. See, I make a guess that A is the bigger of them. Then I check my guess. Well, what is B is bigger than A? If B is bigger than A, well, I better update my answer. Result is B. But if B is not bigger than A, then that was the right guess, and I can return result. This is actually a real common way to program. This is a very, very common way to think. I've got to figure, one of these two is the answer. So I just go ahead and initialize result to be one of them. Then I test that it's really the right answer. If this was not the right answer, then I update to the other answer, and then I return my result. Okay. Okay. So that's a way to write the program. It's a way to find the max of two numbers. Okay. So if I didn't have this, actually, here's an interesting. If you have an integer and you don't put anything in it, did you ever remember what's in a variable, an int, if you don't put something in it?
Is it null?
No, that would be a point. That's what goes into the arrows. The reference variables are null if you don't put anything into them. What's in an integer? They will take a guess. What do you think would be the default value for an integer?
0.
0. Yeah. It defaults to 0. So if I didn't put anything in here, this would return 0 when this was false. But that wouldn't be the right answer. So I initialize it to hold my guess that A is the max. So now results holding my guess, check my guess. If my guess was wrong, update my result, then return the answer. Okay. All right. So, okay. Any last question? Any one of these? Any last question? Oh, I didn't actually put. What's the final answer look like? This is giving an integer answer. It's taking an integer A, and the other input was a B, because that's where this B has to come from. Okay. If B is larger than A, then make result B. And then this is the word return that says, well, that's the answer. So give that answer back to whoever called the function. So that's what the final result would look like. Public static. I'm returning an int because the result is an int. I'm returning an int. That's the name of the function. Takes in two numbers. I'm going to call the answer. Result is a real common name for something that's an answer, but a lot of people actually like to call it answer. Well, this would be the answer. The answer is A, maybe, maybe not. This would update the answer and return the answer. You could also do it that way. Okay. But results are very common. Result is a common variable to mean answer. So we use result as a synonym for answer, what the answer is. Okay. right? So that's what the final that's what the blank should have been filled in with on this one here. Okay. Any last question? And we just ran out of time. Any last question? Oh, the exam is available now. I think at 4:45. So you can go to Brightspace and you can download the exam, look at it, and as I said earlier, if something seems wrong, if you're unsure about something on the exam, you can ask me a question by email if you want a clarification of something. Okay. Any last question? Okay. But I'm trying to remember if there was anything else I wanted to say. Yeah. And you have till midnight. And you upload it right back where you got it from, and you get it from the same place where you were turning in programming assignments. Okay. So I'll go ahead and we'll stop there. Okay. So then we'll meet again on Tuesday. So have a nice weekend and have a good evening, and see you on Tuesday. And if you have questions, let me know. So goodbye.